Hi, guys. Because we've been out of school for so long, I wanted to start to try to implement some lessons over WeVideo, which is obviously my voice while looking at the flip chart and trying to mirror the best I can at or what we usually do at school at home. So we're going to continue on looking at slope in the real world, which is where we left off on Friday. On Friday, because so many students were absent, I figured I would do day 2 again and give you guys an assignment to work on for tonight to try to kind of refresh ourselves with slope in the real world. So some example problems that we have seen before. Okay, and we looked at this one on Monday, or excuse me, on Friday if you were here. If not, we're going to look at these together right now. Question number 8 says, the table shows how much money Sam has saved. Assume the relationship between the two quantities is linear. Write a linear equation to represent this situation. So the first thing that we need to do, or that I need to mention to you, is that I gave this packet out last week. So if you have it, great. If not, please remember that all of my note pages are posted on Google Classroom, so you can find this packet on Google Classroom. Step 1 says to define the variables. The variables are very easily defined as long as we look at the table or the graph that we are given. So if we look at our table, I know that my X is going to be the number of months I saved, and my Y is going to be the total amount of money that I saved. So please remember that your Y is always some kind of total, and your X is the one that you have the ability to change. You have the ability to change the number of months that you are saving for. So we have X as the number of months and Y as the money saved. The next part of this equation says to find the slope or the rate of change. That is simply our jumps. So what we need to do is figure out how much it is changing on the Y over how much it is changing on the X. So on the Y, I know from 10 to 30 is plus 20. Bear with me while I'm writing. And from 3 to 4 is plus 1. So I know my rate of change would be $20 over 1 month. Don't worry about the subtraction they did there, or that I give you an example of. If you need to use the slope formula, you can. But the more quick way to do this would be our jumps. So we know that we are saving $20 each month. Now that we have our slope, we also need our y-intercept, or our starting point. And if you see in this chart, your y-intercept, if you remember, is where your x is 0. It is your starting point. Nothing has happened yet, so you need to have that intercept there. And on the next slide, I have blanked out the beginning portions of the table so we can actually find the pattern. So I know 3, 4, 5, 6. If I move backwards, it would be 2, 1, and 0. Instead of going up 20, I'm now going to go back 20, which would be 90, 70, and 50. Sorry about the handwriting, guys. I need to grab my mouse from the school to help this out. Now, if I wanted to write the equation, or equations, excuse me, I jumped over a step. Our initial value where x is 0 would be $50, so my y-intercept would be 50. When I write my equation, slope always comes first. So my slope would be that change of 20x plus my y-intercept of 50. And that 20 of our slope we found on the previous page. Now it says, how much money will Sam save after 15 months? You know, if you look at your table, that x is the number of months. So I'm going to look at my equation, and where there is an x, I'm going to plug in 15. So if I were to type this out, you would have 20 times 15 plus 50, which would be equal to $350. You're just using that equation and your calculator to help you finish solving. Okay, so I'm going to give everyone a minute to kind of take a quick look at that. You can also follow along on the notes pages posted on Google Classroom, print those out, or you were given those in class on Wednesday, Thursday, and Friday of last week. Okay, let's look at another quick example. Grace is planning to have her birthday party at a skating rink. The rink charges a party fee plus an additional charge for each guest. Write a linear equation or slope-intercept form to model this situation. So defining our variables, once again, is very easy. You have x and y right in your chart for you. So I'm going to go ahead and say that x is the number of guests and y is the total cost. Now, to find my slope, I know that my change here is plus 3. So they are charging $3 over one guest. Even if that y-intercept was not there, you could still find the slope very easily by doing your jumps. So they are charging you $3 per guest. Once again, you do not need to do the slope formula. You can just do your jumps and it will give you the same amount because the rate is constant. The next equation, or the next part of the equation, says to find the party fee or the y-intercept, your initial fee. Before the party even happens, they are charging you to use their company. So that's my starting point. I know my starting point wasn't in here to begin with, but 5, 4, 3, 2, 1, 0 would be my starting amount. Instead of going up 3, I'm going to go back 3, which would give me that $50. And if I wanted to write the equation, slope and then y-intercept, 3x plus 50. I could use this equation to answer any questions that you may have for any number of guests. I could find the price for 30 guests. I could find the price for 150 guests just by plugging right into that X. We're going to look a little bit more today at direct variation, which is the same thing as slope. Slope is a direct variation because the amounts are changing by the same amount. For example, on page 189 in your book, if you have your book, I'll give you a minute to take it out or to find it or to just pay attention and look at while I go. If you see here, this is a direct variation example because the money raised and the biking time are each changing by the same amount. So I have plus 20. And again, I have plus 20. On the other side, I know that my change each time is plus 2 and plus 2. This is a direct variation because the money raised is directly varying on how much time they are spent biking. Every 2 hours, they are making $20. And I know my y-intercepts would be 0 because if you're not biking at all, you're not raising any money at this point for this example. So if I look at this equation, okay, they want you to use your slope formula. You do not need to. By the slope formula, remember you had y2, y1, x2, and x1. So I would have 40 minus 20, y2 minus y1, and 4 minus 2. It's still going to give you that if I did the jumps, 20 over 2. If you do your jumps properly up here, you will have $20 over 2 hours. That's the jumps. When I simplify that, I get that answer of 10. So I know that I am making $10, and here's that 20 over 2 again. And if I simplify it, I'm making $10 every 1 hour. So my answer here would be $10. Sorry, I'm trying to draw a dollar sign for you guys. Over 1 hour. Instead of writing over 1 hour, the hours was the X. So you could simply write this as Y as an equation. Y equals, because our equations always start with Y equals. Y equals 10 I'm sorry, guys. I'm actually going to type this out because it will be easier. Y equals 10 is our slope, $10 per hour, X. And we know our y-intercept was plus 0 because when we were not biking, we were not making any money. So here is the equation that you could use for that. And I will move to just trying to type it all out now, guys. I'm very sorry about the pen. It's just going to be a learning curve for me. So just reviewing, direct variation, okay, is when the two amounts change at the same rate as each other. For example, every 20 was being raised in 2 hours in the previous example. That was constant. Direct variation will happen when your y-intercept is 0. So it's just finding the slope. Slope, rate of change, constant rate of proportionality, constant variation. These are all the same terms. You are still doing the same exact process as you have been. We're going to do the next example together. It is on page 190 in your book. Letter A. It says 2 minutes after skydiving, a skydiver opens his parachute. He has descended 1,900 feet. So in 2 minutes, here's my slope points. In 2 minutes, he has gone 1,900 feet. In 5 minutes, he has gone 4,750 feet. We're going to go ahead. We're not going to put this into a table and make our lives more difficult. We're going to go ahead and use our slope formula. So here you have x1 and you have y1. And over here, we have x2 and y2. You know your formula is y2 minus y1. So I have 4,750 minus 1,900 over x2 minus x1, which would be 5 minus 2. When you do those calculations in your calculator, give you a moment to do that, you get 2,850 over 3. That needs to be simplified to a unit rate. My denominator is a 3 right now. I need it to be for 1 minute. How fast is he falling? 950 feet. So my equation, my slope comes first. Y equals 950x. Now, if the skydiver has not opened his parachute or started skydiving yet, he has not descended any. So it would be, I'm going to add that plus 0 right on the end. So we actually see that our y-intercept is 0. So your equation would be 950x plus 0. That is a direct variation because your starting point is 0. It is a slope of 950 feet descending. Let's look at the next example together. I'd rather do the examples that we can do together, so I'm not on here talking for a longer period of time than I need to be. A grocery store sells 6 oranges for $2. So I'm going to go ahead and underline that information. Assume that the cost of the oranges varies directly with the number of oranges. This situation can be represented by y equals 1/3 x. So here's what they are doing right now. They are telling you that the slope is 1/3. So I'm going to go ahead and label my graph. My y-axis is always a total. We're talking about total cost for those oranges. Your total cost depends on, if you're at the store, how many oranges you are buying. And then you have the cost of those oranges. So I'm going to explain really where this 1/3 is coming from. If I set up a table and I have oranges and dollars, okay, sorry about that, and it is 6 oranges for $2. And the pattern is continuing. At $4, I would have 12 oranges. 2, 4, 6. At $6, 6, 12, I would have 18 oranges. So here's where that 1/3 is coming from. I have a change of plus 2 over a change of plus 6. $2 over 6 oranges, because it's always y over x, equals 1/3 when I simplify it. So I could go ahead and graph my table over 6 oranges up to $2. Over 12 oranges, 12 would be somewhere at the end of this graph, up $4. Okay, excuse me. Yep, up $4. However, what we can do to get another point is move backwards because we don't have our y-intercept right now. So I know instead of going up 6, I'm going to go back 6, so I would have 0. And instead of going up 2, I'm going to go back 2, so I would have 0. So obviously, if you don't buy any oranges, you don't have any dollars spent. So at 0, 0, I'm going to put a point. And then you could go ahead and draw a straight line right there through those 2 graphed points. And I've done this much more neatly on the next page for you. And I will pull away, once again, all of the boxes so you can see. At $0, you haven't bought any oranges, so there's a point at 0, 0. And at 6 oranges, they charged you $2. I showed you exactly where that rate came from on the previous page. $6, 2 oranges, and I graphed it. So there are my 2 points. Couple more examples I want to do together with you on page 193, and then I will post what your assignment will be to work on today. So on page 193, letter D, a charter bus travels 210 miles in 3.5 hours. So we're going to use some points here to help us find our slope. So the one thing that we need to do first is understand that X, if we are talking about traveling, okay, our Y is always a total. We're talking about total miles. Our X then has to be the number of hours. That's the only other possible thing we're talking about. Now, if I wanted to make some coordinate points so I can find my slope, X always comes first. So my first hour was 3.5 hours. I'm going to write that as 3.5. And I traveled 210 miles. Now, you might say, Ms. Ferraro, there's only 1 point here. However, we can make another point. If you have not left, if the charter bus has not left at all, they have spent 0 hours driving and they have not gone any distance. So another point could be 0, 0. So when you do your slope formula, remember, you have x1, y1, then x2, sorry guys, and y2. So y2 minus y1 would give me 210, and x2 minus x1 would give me 3.5. So I would have, if I did my slope formula, 210 over, I'm going to write it this way, 210 over 3.5 hours, which would be equal to, if I simplified, I believe all of this is written out somewhere. Yep. Which would be equal to 60. $60 miles over 1 hour. If I wanted to write that as my equation, which I know we always do, we have y equals, my slope was 60 miles, which is x, over 1 hour, plus our starting point. We didn't have, if you have not left yet, you have not traveled any miles, so it would be plus 0. So there's a great equation we could use. Last but not least, a monarch butterfly can fly 93 miles in 15 hours. So once again, the first thing we need to do is understand what our X and Y are. Y is always a total. So in Y, we're talking about the miles that that butterfly can fly, and X would be the number of hours it is flying for. So right now, I know that I can set up my slope-intercept form to help finish this equation. So I know that if I set up my slope coordinates or my slope points, your first point, the butterfly isn't flying any hours, and that means it's going no miles. So your first point could be 0, 0. Your next point, you know that in 15 hours, because 15 is the x, it goes a rate of 93 miles. Now, if I use my slope formula to go ahead and solve this equation, it would be y2 minus y1. So it would be 93 minus 0, which I know is 93, over 15 minus 0, which is 15. That would be your rate, 93 miles in 15 hours. And if I go ahead and simplify that in my calculator, I get an answer of 6.2. So my equation, here is my slope. My equation would be y equals 6.2 x for the number of hours, 6.2 miles per 1 hour. There's the hour, because hours is the x, plus our starting point, which was 0. Now, it says, write and solve a direct variation equation. Here it is, 6.2x plus 0, to find how far the monarch butterfly will travel in 24 hours. I know that x is my number of hours. So right where that x is, I'm going to go ahead and plug in a 24. 6.2 times 24. So in 24 hours, that butterfly will fly 148.8 miles. This was just a quick recap of everything we covered on Friday. What I'm going to do is, as I said, I will post the note page with all of my filled in information. I will post the assignment, and I will post this video to help you through your assignment tonight. Please take the time to watch these videos. They are going to be very helpful, especially as we start to cover new content. And I will hopefully be able to somehow set up a live video chat to try to answer questions that you guys may have. I hope this was helpful as a review. I miss you all very much, and this is going to be a working process. So please let me know if you have any questions on the assignment, and please make sure to continue to check Google Classroom. I hope you guys are safe and healthy and have a wonderful afternoon.